In today's lesson, students will be able to subtract integers by adding their opposites. Students will be able to find the distance between two integers on a number line. So technically, we don't subtract integers, right? What we do instead is we add the opposite number. We have an acronym that's called keep, change, change. So for example, here, because I see a subtraction sign, now I want to make it clear, only because I see it, not because I do it. So off topic, over here to the left, like -5 plus 8, right? I don't see subtraction. But because signs are different, I technically subtract, and 8 minus 5 is 3, and it's going to be positive 3 because 8 has a bigger absolute value than -5. There I performed subtraction. You're not going to use this new acronym when you do subtraction, only when you see it. So in this problem now, right, because I see a subtraction sign, I see a minus sign, I'm going to use an acronym called keep, change, change, right, as an addition problem. So I'm going to keep the 10 alone. I'm going to change the minus sign to a plus sign, and I'm going to change positive 25 to negative 25. And now I'm going to solve it using my addition rules from last lesson. Here, because signs are different, I subtract. 25 minus 10 is 15. And then once again, which one has the bigger absolute value? It goes back to like players I mentioned before. The positive team has 10 players. The negative team has 25 players. The negative team's going to win. Negative 25 has a bigger absolute value than positive 10. So the answer is negative 15 and not positive 15. All right, example 2, same thing. Because I see subtraction, I'm going to keep, change, change. I'm going to rewrite it as 21 plus negative 30. And I'm going to solve that instead. Once again, here, signs are different, so I'm going to subtract, and the answer is going to be 9. But because the negative side has more players than the positive team, it's going to be negative 9. Number 3. Once again, I see subtraction, so I do keep, change, change. The 32, I leave alone, right? I keep it. I change the minus sign to a plus sign, and I change negative 8 to positive 8. Solving 32 minus negative 8 is no different than solving 32 plus 8. Obviously, 32 plus 8 is much easier to solve. Signs are the same, so I add, and my answer is 40. I'll do one more, and then I'll move on to the word problem, so you can complete the rest on your own. And number 4, once again, I see a minus sign. So keep, change, change. So I leave negative 15 as negative 15. I change the minus sign to a plus sign, and I change negative 21 to positive 21. Here, signs are different, so I subtract, and I get 6. This has more players, this has a bigger absolute value than this number, therefore my answer is positive 6 this time and not negative 6. So once again, you can do the other ones on your own up until 9. 9, I'll actually do that with you right now. So 9, use the space below, be a little bit easier. Negative 19 minus negative 7 minus negative 6. The keep, change, change only works for 2 numbers at a time. So you can only do it 2 numbers at a time. So I'm going to keep, change, change. Some kids do like this, keep, change, change. Yeah, if it was that easy, everyone would be good at math, right? Unfortunately, you can't do that. So it's only 2 numbers at a time. So I'm going to keep negative 19 as negative 19. I'm going to change the minus sign to a plus sign, and I'm going to change negative 7 to positive 7. And I'm going to solve that first. Negative 19 plus 7, signs are different, so I subtract. 19 minus 7 is 12. But it's negative 12 because this has a bigger absolute value. Then I bring down the other symbols. See, I won't bring down anything else because I already used it. So I'll bring down the minus sign, and I'll bring down the negative 6, and then I'll just do keep, change, change again because I see another minus sign. Keep, change, change, negative 12 plus 6. Signs are different, so I subtract. And the negative has more players than the positive, so therefore my answer is negative 6. And that's the answer to number 9. So go ahead and do the rest on your own, and I'll check it in class. All right, this is part B of 2.2. Find the distance between 2 integers on a number line. We're trying to find the distance between 3 and 7. So here's your number line. I like to use 0 to help me. On a number line, 0 will be to the left. 3 would be here, and 7 would be roughly here. If I had to count from 3 steps to 7 steps, I would have how many steps? I would have 4 steps. So in short, I subtract the two numbers. But I just want to make it clear, I'm only subtracting the two numbers because they're both on the same side as the 0. If you look at the second problem I'm going to do with you, it's a little different. So I'm going to do method 1, but the number 2 problem. Same thing, I'm going to draw my number line. Here's -6, here's 0, and here's +2. This one's a little bit different. I'm not going to subtract the two numbers like I did above. Instead, if you think about it, the amount of spaces, or how many steps, between -6 and 0 is 6. The amount of spaces from 0 to 2 is 2. So the amount of steps between -6 and 2 is going to be 8. In this problem, I actually added the absolute values of both numbers because they're on opposite sides of 0. Now I'm going to show you both methods with the absolute value method. So using the absolute value method, these little bars here means absolute value. Because you're finding the distance of two numbers, you're always subtracting. So in this case, it'd be 3 minus 7. And in this case, it'd be -6 minus 2. Well, 3 minus 7, right? We do keep, change, change. So keep, change, change. It's going to be -4. But the absolute value of -4 is +4, which is the same answer we got here. Absolute value just means distance from a number and 0. And distance is always positive. You can't be -5 feet tall, for example. So whenever you have an absolute value, no matter what, if it's positive, leave it positive. If it's negative, you have to change it to positive because absolute value means distance, and distance can never, ever be negative. Let's do the next one. So here, -6 minus 2. Once again, we keep, change, change. Now it's -6 plus -2, and it's going to be the absolute value of -8. But the absolute value of -8 is 8. So both methods get you the same answer. Do the other ones on your own, and that is it for today.